The simulation hypothesis is compelling because it feels modern. It borrows the language of computers, code, and digital worlds. It aligns with an age shaped by artificial intelligence and virtual spaces. But compelling ideas are not always correct, and serious questions require serious balance. This video explores why many scientists and philosophers remain unconvinced. Not because the idea is foolish, but because extraordinary claims demand extraordinary restraint. And when examined carefully, the simulation hypothesis faces major problems. Human brains are pattern-seeking machines. They evolved to detect agency and intention. When something complex exists, we instinctively look for a designer. This tendency once helped humans survive, but it can also mislead. The simulation hypothesis offers a familiar narrative, that someone is in control and that there must be an explanation behind the curtain. Uncertainty becomes intentional rather than accidental. That psychological comfort should make us cautious, because ideas that feel right are not always true. Quantum mechanics often sounds unnatural. Particles behave unpredictably. Observation changes outcomes. Reality seems incomplete until measured. However, observer does not necessarily mean consciousness. It means interaction. A detector, a photon, or a measuring device is enough. No awareness is required. There is no evidence that reality waits for minds to exist. Quantum mechanics is strange because the universe is strange, not because it is artificial. Mistaking unfamiliar behavior for design is a common error. Science advances through testable claims. A theory must risk being wrong. If an idea cannot be disproven, it cannot be strengthened. The simulation hypothesis struggles here. Any evidence could be explained as part of the simulation. Any absence of evidence could be deliberate concealment. That makes the idea immune to testing. This does not make it meaningless, but it places it closer to philosophy than physics. And philosophy asks different kinds of questions. Simulating reality is not trivial. The universe operates at extraordinary precision. Every particle interacts with countless others. Every moment requires vast amounts of information. To simulate even a small region in full detail would require astronomical resources. Simulating an entire universe may be infeasible, even for advanced civilizations. However, efficiency arguments cut both ways. If a simulation is simplified, inconsistencies should appear. So far, none have been observed. Reality behaves consistently, even where no one is looking. The universe appears delicately balanced. Small changes to physical constants would prevent life. This feels improbable. But improbability alone is not evidence of design. One explanation is selection bias. Only a universe capable of supporting observers can be observed. That makes fine-tuning inevitable from the inside. Another explanation is necessity. The constants may be the only values that can exist. Unknown physics may yet explain what feels miraculous today. When multiple explanations exist, science prefers the simplest. This is known as parsimony. Base reality requires fewer assumptions. The simulation hypothesis adds layers. Advanced beings, vast computing infrastructure, motivation to simulate ancestors, a reason to conceal the truth. None of these is impossible, but each one is an additional assumption. And assumptions weaken explanations when the evidence is equal. Bostrom's trilemma is logically elegant, but it rests on uncertain premises. It assumes civilizations survive long-term. It assumes they choose to run ancestor simulations. And it assumes simulated minds vastly outnumber real ones. If any of those assumptions fail, the probability collapses. Logic alone cannot determine which future choices advanced beings will make, and statistics without data can only remain as speculation. Even if reality were simulated, meaning would not disappear. Pain would still hurt. Joy would still matter. Love would still feel real. But importantly, reality does not need to be artificial to be meaningful. Meaning arises from experience, from connection, from consciousness itself. Whether the universe is fundamental or emergent changes little about how life is lived. The value of the simulation hypothesis is not its answer. It is the discipline it demands. It forces careful thinking about evidence, about assumptions, about the limits of knowledge. It reminds us that not every mystery has a satisfying explanation, and that uncertainty is not a flaw in understanding. It is part of it. Science does not currently support the idea that reality is simulated. It also cannot definitively rule it out. That tension is uncomfortable. But it is honest. The universe continues to behave consistently. Its laws remain stable. Its patterns repeat. Nothing yet requires an artificial explanation. The simulation hypothesis asks a bold question. But bold questions do not demand bold conclusions. Sometimes restraint is the most intelligent response. Reality may be base, reality may be emergent, or reality may be something we do not yet understand. What matters is how carefully we ask the question, how responsibly we interpret uncertainty, and how willing we are to accept mystery without inventing answers. Whether this universe is simulated or not, it remains vast, lawful, and astonishing, and it does not need to be coded to be worth understanding. Join us every Sunday for in-depth stories, thought-provoking questions, and extended explorations that delve beyond the short videos. Because knowledge doesn't stop at 60 seconds.
Thanks for watching. This is 60-second knowledge now extended. Because curiosity doesn't stop at 60 seconds. Subscribe on YouTube and follow us on TikTok.